Yes, so let's now look into the next question, question number 12.
You are flying from S to T, which is the required track of 272. This is 270, so it's 272. Like
So what's the required track?
it's 272.
So the required track is the planned track of 272 degrees
Yeah.
true. Yeah.
Yeah. From S to T. So S will be towards east side, T will be towards west side, and it is 272 degrees.
That's right. From S to
U T.
T. That is the track of 272 degrees true. Yeah. Now what are we finding? So it's 50 nautical miles. 50 nautical miles is from T. So this distance is 50 nautical miles. This is from T. Therefore this is 50.
50.
Right? Now you find yourself 5 nautical miles right of required track. You're traveling from S to T. So this is the track. And you're right of the required track. So you're somewhere here. This is point C. Right? And so you have this your 1 in 60 fix here. Say for example, if I have a big lake, and now you find that you are right of this lake, which will you will have an idea that you have drifted off to the right. Right? What's the question? You have to find out what track must you fly to arrive overhead T. That's nothing different from the previous question. Right? The track which you're supposed to fly to reach overhead T. So I'll give you some time. You can try this. Track required to fly overhead T. So now you know which where to look into. Track error doesn't really matter.
Yeah.
Right? Yeah. So we have the previous question which you can actually refer to. It's exactly the same.
Yeah. It's 6 degrees left.
Yeah. So how far are you drifted from 5 nautical miles to right? Right?
5 nautical miles. Yeah.
Right. So basically 50 nautical miles to go, and you're 5 nautical miles off. Therefore, applying 1 in 60.
60 rule.
Yeah.
We need to find the closing angle since we have to fly over at T.
Exactly. So first thing first, you're actually flying a tracker. Don't do anything about it. You keep drifting off like this. So first thing is you stop the drift by flying a track of 272 degrees true, the same track, right?
Yeah.
Which will take you on a parallel track, and they're going to stop the drift, right?
Yeah.
Now you have to now fly further to the left by a certain amount if you want to track overhead T, and that is exactly equal to what? The closing angle, because it's two parallel tracks cut by a transversal, and therefore these angles are same. So 1 in 60, you're finding the closing angle, which is distance off by distance
By distance to
to
go
go
into 60.
into 60. So what is distance off?
That is 5 nautical miles divided by 50 nautical miles multiplied by 60.
60.
Then 60. So it's
Right.
gives me 6 degrees.
6 degrees. Right? You see you're 5 nautical miles off, and you just have 50 nautical miles to go. That's why you have such a huge closing angle. Right? Remember, you can still apply 1 in 60 because it's less than 20. Angles more than that, first thing first, you should not be drifting so much. Your navigation skill is like extremely poor. Second, you cannot apply 1 in 60 because it's going to be rainy. So you have to apply tan theta then, but you won't get such questions at all, right? So 6 degrees, therefore now it's very, very easy. 272, 6 degrees to the anti-clockwise direction. What's the track?
Yeah. Left.
Minus 6.
So 266 degrees true.
266 degrees true. Right? Now if you bring heading in the picture, the final heading required, you have to find the track error, and for that you have to have total distance, and depending upon how you assume total distance, that's going to change. We saw that in the previous question, right? As far as this question is concerned, the answer is 266 degrees, right? Perfect, true. Alright, let's look at the very next question. This is all these next set of questions are also dealing with some hardcore 1 in 60 applications into navigation, right? Let's do the first question in that series. Do you have the PDF? Do you access it?
Yeah.
Right? Question number 1. If an aircraft is 3 degrees off required track at a range of 120 nautical miles, track error is given, 3 degrees off track. At a range of 120 nautical miles, how far nautical miles is the aircraft off the required track? That's a very simple question. I'll give you some time, you can try out. Draw very quick diagrams for the examiner. That's going to re-emphasize your answer every single time. And as I've told you, put the question numbers in your rough answer sheet, draw it systematically, write the steps properly. So when you want to come back and check it, you have it in the order. Otherwise, you have to redo the whole thing again. So might not be very significant or very clear for these kind of questions. When it comes to questions concerning performance or CPP all those payloads and all, it will become a problem if you just mess it around. So just write in a particular order, and that's going to help you.
It's 6 nautical miles.
That's it. Do we have to kind of do anything over here? It's 3 degrees over 120 nautical miles. So if it was over 60 nautical miles, it would have been 3 nautical miles. Now you're going further away with the same drift. That's going to increase your distance off. Just the way what happens if I did not do anything about it and keep drifting away, your distance is going to increase. Over 120 nautical miles, it's going to be double your track error, and therefore it's going to be 6 degrees.
6 nautical miles.
6 nautical miles, correct. 6 nautical miles off track, right? So if we are to do that question, it doesn't matter what your track is. I can draw any given track here, which is a planned track, and that distance is given as 120 nautical miles. You are off by 3 degrees. What is this 3 degrees? That is your track error, and this will be your track made good. And after 120 nautical miles, you found yourself left or right. Is anything of that sort given? Nothing is given. Therefore, you have to find out this off distance.
Yeah, that is X. Right? We can take.
Right. So you can apply 1 in 60 here, and that is track error is
equals to distance off by distance gone
into 60. That is distance off.
Distance off. And 3 is equals to distance
equal to track error is 3 into distance gone is 120 nautical miles divided by 60, which is 6 nautical miles. Remember, you should reach a point where you shouldn't be doing this to find answer to these kind of questions, because in the aircraft the whole idea is to learn this is not just to clear the exam, but when you fly you should be able to understand this without minimum amount of calculation. So here you can see a calculation is not required. 3 degrees over 120 has to be 6 nautical miles, right? Or 3 degrees over 30 has to be 3 by 2 nautical miles, 1.5 nautical miles. Right? Perfect. Yes. Next question. Question number 2.
If an aircraft is 2 miles off the required track at a range of 40 nautical miles, what is the angle? That is the track error.
That's what the angle off track, which is the track error. Correct.
Degrees.
Yeah, so basically, an aircraft is 2 miles off the required track at a range of 40 nautical miles. You travel 40 nautical miles. It doesn't matter what your track is, you travel from point A to point B. You travel 40 nautical miles, you are off by 2 miles. Remember, in the question, if nothing else is mentioned, 2 miles is nothing but 2 nautical miles. Right? It's not statute miles or anything else, it's nautical miles. Right, so this is 2 nautical miles here. That is what is given as just miles in the question. Alright, what is the angle off track? The angle off track is basically the angle between your planned track and your track made good, which is your track error. And that's just track made good. So how will you find out? Over 40 nautical miles. How will you find the track error? Track error is equal to applying 1 in 60.
That is distance off by distance gone multiplied by 60.
60.
The distance off is 2 nautical miles. Distance gone is 40 nautical miles into 60. 3 degrees.
That's going to be 3 degrees. And remember, track error has to be left or right. So are always measured from the planned track towards the track made good. Therefore, it is 3 degrees right track error. Right? Basically, either if it is because of wind, we assume it's more like a port wind giving a starboard drift. Right? All right. Yes. Happy with that? Question? Question number 2? All right. Question number 3.
An aircraft leaves A to fly B, 95 nautical mile distance.
So AB is given as how much?